All right, good morning or good afternoon, depending on which class period you're in. This is my first time trying this. I'm cheap and I have the free version of this, so they're only going to allow me to talk for 15 minutes. So please make sure before we start that you're paying attention, because some of y'all don't do that when I'm there. Make sure you're focusing, make sure you're silent, and make sure you have out a sheet of paper because we're starting right now. By the end of this video, you should have completed on this sheet of paper 4 do now questions, very brief notes. You should have both examples that I'm going to do written and an exit ticket that consists of 4 questions. Starting now. So here's our do now. Um, we have a chemical equation at the top of the screen. But before we talk about chemical equations, number one says, what is the name of CH4 and CO2 in the chemical equation above? You should be pretty tired of this, but CH4, carbon is a nonmetal, hydrogen is a nonmetal. So this is a covalent molecule, so we need to just name it with prefixes. There's 1 carbon, there are 4 hydrogens. And then CO2, there's 1 carbon and there are 2 oxygens. Both are also nonmetals. It's covalent as well. So CH4 should be carbon tetrahydride, 4 for tetra, 4 for the 4 hydrogens. And carbon dioxide is pretty simple. Number two, how many hydrogen atoms are on the left side of the arrow? Well, looking at the top of the screen, we see where the arrow is. We're talking about the left side. We're going to count how many hydrogens we see over there. So there's a coefficient in front of CH4, carbon tetrahydride. How many hydrogens would there be over there? Well, if I have 2 molecules of carbon tetrahydride, 2 times 4, that would be 8 hydrogen atoms. How many hydrogen atoms are on the right side? On the right side, I only see H2 in water. There's no coefficient there, so there are just 2 hydrogen atoms on the right side. Number four, this is an opinionated question. And I know how some of you do with opinionated questions, but whatever. Do you find any issue with the answers that we just got in 2 and 3? Well, maybe you don't have any issue with it, but I have an issue with this because if I have 8 hydrogens on the left, there should probably be 2 hydrogens on the right. That just doesn't seem correct. And maybe we'll learn why in a second. Cool, done. All right, here's the standard. You can look at that later. We're starting right now. So now you should be taking notes. You only need to write the things that are in red. You only need to write the things that are in red. You could probably already get started while I'm going to say it again. You only need to write the things that are in red. So a chemical reaction is a process that rearranges molecules. At the top, we have what is known as a chemical equation, which symbolizes the starting materials and the end products when these molecules react. In the picture, you probably see something that maybe you've done in middle school and something that we're probably going to do when I get back. But at the top of the screen, we have acetic acid, which is better known as vinegar. And we're going to add it to sodium bicarbonate, which is baking soda. That's what that addition sign means. We're going to mix 2 things together to create, that's what the arrow means, sodium acetate, water, and carbon dioxide. So these things are going to mix together, and these molecules are going to rearrange themselves to create a new product. In a chemical equation, you have 2 things. You have your reactants. These are the molecules that you start with. They're typically on the left side of, no, not typically. They're always on the left side of the arrow. So our reactants in this equation would be acetic acid and sodium bicarbonate. Then, once you mix those things together that you're starting with, you're going to create or produce, that's what the arrow means, your products, which are the molecules that you end with. So our products in this equation would be sodium acetate, water, and carbon dioxide. I think it's pretty easy. You just need to know that your reactants are on the left and your products are on the right. Law of conservation of mass. You should be tired of laws of conservation. Any law of conservation is going to say X cannot be created or destroyed, just rearranged or transferred or whatever. In this case, we're talking about mass. So mass cannot be created or destroyed, just rearranged. In other words, the amount of mass that you start with is the amount of mass that you will end with. At the top, we have coal, 100 grams of coal on a scale, and it's covered with a dome. Let's say we burn that coal somehow. And after the coal has been burnt, even though it's significantly smaller, the scale should still say 100 grams because although the coal has been burned, it hasn't been destroyed. It's just been rearranged into maybe some other type of gas, a little bit of oxygen, a little bit of carbon dioxide, and maybe some other gas. But it should still be the same. The amount of mass you start with is the amount that you end with. So, in a balanced chemical equation, ugh, move that up. In a balanced chemical equation, the number of atoms on the left side in your reactants have to be equal to the number of atoms in the products. If that's not the case, the equation is not balanced. So let's see if we can figure out if this equation is balanced. The way that you'd figure that out is by counting the atoms. So let's look at our reactants. Fe, iron. How many iron atoms are on the left? 2 times 2 is 4. How many oxygen atoms are on the left? 2 times 3 is 6. How many carbon atoms are there? Please understand that that coefficient of 2 does not apply to these carbons over here. Carbon has its own coefficient, which is 3. The subscript for carbon is 1. 3 times 1 is 3. Let's look at the right side. How many irons do I have? 4. How many oxygens do I have? The subscript for oxygen is 2. The coefficient in front of it is 3, so 3 times 2 is 6. How many carbons? Carbon has a subscript of 1, again, 3. 3 times 1 is 3. Is this equation balanced? Well, let's look. Do we have the same number of atoms on both sides? Yes, so this equation is balanced. Now let's learn how to balance equations. You can pause the video to write all 4 of these steps that you see on the right side. But other than that, I'm going to keep going. Or maybe you could just look and understand. But you do need to write these examples. The first thing you need to write is this equation. P4 plus Br2 creates PBr3. The first thing we're going to do is make what is known as a wrap table. And no, not the terrible music that we all love. I'm talking about reactants, atoms, and products. The way that you're going to make a wrap table, you're just going to draw 3 lines. Here's the first line, here's the second line, here's the third line. Don't act like this should take you a year to draw, because if I was there, this table would look a lot less pretty. Then we're going to put R, A, and B. Done with step 1. You should be done writing this table for all of the artists that I teach. Number 2, we're going to list all of the single atoms that are present in our reactants. Where are our reactants? They're on the left side. So we're going to see all of the atoms that are present. Well, I see P, phosphorus. The next one I see is bromine. Are there any other atoms that you see on the left side? No. And guess what? We should have the same atoms on the right, so we don't even really need to look over there. Number 3, now we're counting the atoms and react in our reactants and our products. Let's look over here. How many phosphorus atoms? 4. How many bromine atoms? 2. Now let's look at our products. How many phosphorus atoms? 1. How many bromine atoms? 3. Cool. The fun part and the hardest part, I guess. We're now going to add coefficients and adjust our totals on each side until this equation is balanced, or until we have the same number of atoms in the reactants that we do in the products. Okay? So, first thing we're going to do, we should add our coefficients to bring the number of atoms up. So we're going to look at this wrap table for each atom. You should be asking yourself which side of the equation needs to be increased. Let's start with phosphorus. If we have 4 atoms of phosphorus in the reactants and we have 1 atom of phosphorus in the products, which side needs to be increased? Well, obviously, our product side needs to be increased because there's only 1. We should now ask ourselves, what coefficient, I didn't say subscript, what coefficient can we add to give us 4 phosphorus atoms? Well, if the subscript is 1, the only coefficient we can put there to give us 4 would be 4. 4 times 1 is 4. Now we need to adjust our table. So if we put a 4 in front of this, how many phosphorus atoms do we have now? Well, 4. You got to change that in your table. Either erase it or cross it out, but just make sure you change it. Now, when we added 4, we need to now see, did any other atom get affected? Well, if you put a 4 in front of PBr3, that didn't just affect P, that also affected bromine as well. How many bromines are there now? Not 3. 4 times 3 is 12. Awesome. Now, our phosphorus atoms are balanced. We have 4 on each side, but now our bromines are unbalanced. So, which side should we increase? It should be the reactant side because we want to work our way up to 12. So, what coefficient can I add in front of Br2 to give me 12 bromines? Well, if you went to second grade like I did, my teacher, Sarah Urshan, taught me my times tables. So I need to be asking myself, what times 2 will give me 12? I know if I put a 6 in front of this, that will give me 12 bromines. We adjust our tables, our totals. So it's no longer 2, it's 12. Ooh, is this equation balanced now? Guess what? Yes, it is balanced. That is our balanced equation right there. P4 plus 6Br2 gives us 4PBr3. It's balanced. Turn up. All right. So, what I like to do, I like to rewrite the balanced equation and put a box around it. I said rewrite it because it's going to change a lot and I don't like to see a lot of mess. So, just rewrite it. Now, do this one on your own. You should pause the video and do it on your own if you're actually about it. If you're not about that life, then you're probably just going to let it keep playing and let me explain it. But whatever. This example is going to be much shorter because typically in class, the second one, I go through it pretty quickly, so I'm not going to explain it as in depth as I just did. So here's our equation: N2 plus H2 creates NH3. We're going to make our RAP table. I already have it right here. Then we're going to list all of the atoms that are present in the reactants. There's only nitrogen and hydrogen over there, so put that there. Then we're going to count our atoms in the reactants. How many nitrogens? 2. How many hydrogens? 2. Products. How many nitrogens? 1. How many hydrogens? 3. Cool. Now we're going to add coefficients to bring our atoms up. So, as far as nitrogens, I need to bring that up to 2. What coefficient can I add to give me 2 nitrogens on the right? It'll be 2. Change it in the table. That should now be 2. Then, when I changed that, that didn't just affect nitrogen, it also affected hydrogen. So there are no longer 3 hydrogens, there are 6. Cool. Now we got to go to the left side and bring our hydrogens up to 6. What coefficient can I put in front of H2 to give me 6 hydrogens? Well, that would be a 3. So then we change our totals. 6. Is this balanced now? Yes, this is totally balanced. Yay! N2 plus 3H2 creates 2NH3. Cool. All right, so here's our exit ticket. At the top, I have 4 questions. They are all pretty simple. It says balance the following equations if necessary. One of these, it's not necessary to balance them because we have the same number of atoms on both sides. It's just up to you to figure out which one does not need to be balanced. So, what you should turn into the substitute or Miss Jackson before you leave, you should have this paper that has 4 do now questions. You should have the brief notes written, both examples that we did, and these 4 questions answered. I will be grading them. I will be grading them. I do expect for you to have learned a great deal from this video. I do believe it's just the same that it would be if I was in class, except maybe I'll be yelling a little bit louder and I'll be hitting on tables for certain things. But other than that, you should be fine. You can go back, rewind. You can ask Miss Jackson to go back and rewind if she's playing it for you guys. Other than that, cool. I'm done. Do your exit ticket and don't act a fool.